So in this particular video, I want to introduce you to the idea of SourceBoost IDE. Now SourceBoost is a C compiler, and what we can do is we can type up a C program for the PIC microcontroller, and the PIC microcontroller we're going to learn about this semester is the PIC 16F84A. So I can type up a program written in the C programming language using this SourceBoost package. Now it's an IDE, and that stands for Integrated Development Environment. So SourceBoost IDE is a free piece of software that we can download from the internet and that we can use to develop C programs for a PIC microcontroller. So the first thing to do is to look around on your desktop and then find the icon, and the icon will look something like this. And if you double click on that icon, the program will start to run. So let's start running the program now. So it starts to flash up, and after a minute the SourceBoost screen appears. Here is the SourceBoost screen. Now I've made it a full screen, okay, so it's easy to see. Now first thing that happens is this tip of the day comes up. Now I don't find this particularly useful, so I'm going to close that tip of the day. So you can exit up here, or you can hit close. Now what's happening is SourceBoost is looking for the last program that I was working on. And the last program I was working on was a program called ledflash.c. Okay? Now in this short video, what I'm going to show you is how you open a project in SourceBoost, how you then open a C file in SourceBoost, and how you compile and link a program in SourceBoost. So let's start off at the first step. In SourceBoost, everything is a project. And basically it's going to be a standalone project as shown up here on this part of the screen. This is called a workspace, and this is what I'm working on at the moment. Now what I'm working on is I'm working on a program, and that program is actually part of a bigger project, because this program file I also create another set of files because I've written this file here. So the whole thing here that I'm seeing is in fact a project. So what we need to do first of all, and it's a bit unusual, is we need to open up or load a project. So what we need to do is go up to workspace and click, and then go down to standalone project, and then go down to open project. And when I click on open project, where I store all my projects will come up. Now normally what you have to do is go to my computer and then look maybe at your C drive, and here's my Boost C7 programs. So if I click in here, here's all my projects, and you can see I have a number of different projects. Here's some of them, and here's more of them down here, and all of these projects are SourceBoost projects. So what I want to do is I want to open up the very first project that I'm going to work on. And the very first project I'm going to work on is LED Toggle. Now it's not open at the moment, instead I have a different project over here called LED Flash, but I want to open LED Toggle. So I've highlighted LED Toggle and I click on open. And what happens now, if we watch over the workspace, it's changed. I now have LED Toggle.c. So the project here is called LED Toggle. You can see it up at the top of the screen, and here's LED Toggle.c. If I double click on that, I can see the C program that I wrote to actually basically turn a LED on and off. It's the very first C program that you write for any microcontroller. So here is the C program, and the first lines of this C program in green here are comment lines, and any of the lines that you see over here as well and here, they're all comment lines. So the lines that I'm highlighting now, those lines there are comment lines because they're coloured green. That's a comment line there because it's coloured green, and this is a comment line here also because it's coloured green. After that I've got this hash include system.h preprocessor command, and I'll explain in the lecture what that's doing. I declare a function called delay, and it's a void function, so it takes no values and it doesn't return any values. And here is the main part of the program here. This is the function, and in and what I'm going to do is I'm going to inside an endless I'm going to send a logic 1 second, down, I can see my little, and in this little delay five, six, seven, eight, nine. Playing hide and seek. Order to count from 0 up is roughly 1 way of doing it. So I have a piece of code, this standard order to do nothing or wait for 1 is the code. I've written the code. It starts up here, finishes right down here. What I have to do when I'm trying to create executable code is I have to do a two-step process. So the first step is to press this C for compile. I've got to compile the project. So if I press C for compile and I watch down here, you should see eventually it's compiling and then it says done. Now if there's a problem, if you've made a typing mistake, you'll get some sort of error message there. But you can see because this program is pre-written for you, you won't have that problem. So just say success and done or just done. And that means that there are no typing mistakes in that C program. The program has been partially translated into machine code. The next step is to link the program. So this symbol here, L, that is to link up the various different parts of your program. You have two parts to the program, the main function, and you've also got the delay function. They have to be linked together. If I press L for link now, again you can see that we're linking and we've got success and done. So basically what's happened is this C program has now been properly translated into machine code, or hexadecimal code as it's sometimes called. Now if you want to prove to yourself that that has happened, we can look at this file here, ledtoggle.hex, and if I double click on it, here is the machine code version of the program, and really what it is, it's just hexadecimal numbers. It's numbers between 0 and F, and they're just strings of numbers, and this is really the machine code that my PIC microcontroller can understand. So that's the code that I am going to send to my PIC microcontroller to get the LED connected to port B line 0 to turn it on and off. So that's the hex code. I have written this code, C code. I have to get this hex code, and what the SourceBoost is doing for me is it's translating this C code into this hex code, and that's the usefulness of SourceBoost. It does all that job for us. Now I can type out my own programs. This is a pre-written program, and I've looked at this program in the notes and I've explained how it works in the notes. So that's how you compile, by pressing C, and you have to do that first, and then that's how you link, by pressing L. Now sometimes we might not want to compile and link. What we could do instead is we could do the following. We could use this B for build all, and that will automatically compile and link. So let's press B for build all and see what happens. And again you can see down here it now says building, and it's working through the whole thing. Okay, now there is a slight problem with this here. Sometimes build all doesn't work, so I've got a failed message down here. So depending on what way SourceBoost is set up, you might or might not get that, but we can definitely C for compile and L for link. They're the two steps that we want to do. B for build all may or may not work, and sometimes we have to change the settings up here to get B for build all to work. So we won't worry about that for the moment. Your main task is to understand that you have to go to the workspace to open the standalone project. So you go to standalone project, open project. Now the project I opened was LED Toggle. Okay, so I'm finished with that project. I've built it, I've compiled it and linked it. Let's look at the next one, LED Flash. I click on that and open it. And now you can see I've changed. See, there's LED Flash.c here now. And here is LED Flash. This is the project I'm working on. I double click on it. I'll just maximize the code over here. And you can see that it is a different program. It's not the same as the LED Toggle program. And once again, I've got to go to C to compile. and it should start compiling down here for me, and you can see it is, and it's done that for me. Thank you very much. And then I go L for link, and it's going to link up the various parts of my program. It says success and done, and once again I've got a hex file. Here's the hex file. It's different hex code, of course, because the LED flash program is different to the LED toggle program, but there's all the hex code again. So once again, my C program has been translated into hexadecimal code using SourceBoost IDE. So that's the strength and the beauty of SourceBoost. The main thing to remember is that you go over to the workspace, you go to standalone project, and then you have to open the project. And then you select one of these projects here that we'll be working on for the first half of the year. So we've loads of different projects to look at, and we'll eventually be getting you to modify and change these projects and the programs associated with the projects yourself. So I'm just going to cancel that, guys. Now if I exit out of SourceBoost, if I close it down like this, let me just exit there. I've exited out of SourceBoost. Now if I go back into SourceBoost, it should remember that I was working on that LED flash project. So let's go back in for a second. I'm firing up SourceBoost again. I again get this tip of the day nonsense, which I just close. And look, it has remembered that I was working on LED flash. There it is as before, and there's the code. To look at the code, you need to double click on it. So if you want to look at any of these files, you just double click on them. So if there's ledflash.hex, double click on it and it will open up. They're normally miniaturized like this, but I like to look at them in big windows like that. And you can click between them like this. So you can switch between ledflash.c and ledflash.hex. So that's it, guys. That's your introduction to SourceBoost. Thanks for listening.